Welcome to you all again for this project management workshop, 5th day. So if you have any question, we can take this, and otherwise you can go on directly on to the cost management. We can recap what we discussed in the last session, and then we'll continue where we left. So any question? Should we start with cost management?
Yes, we can go ahead.
Okay. So in the last session of cost management, we discussed about estimating and budgeting, and when we come to controlling, we stopped and say we will carry on the next in the next session. So let's recap what we discussed in estimating and budgeting the cost. So first of all, we talk about the cost management plan. So plan cost management is a process which is required to develop a cost management plan that will guide us for how to estimate, how to budget, and then how to control the cost to keep the project under control with respect to the cost. Okay, the main couple of things which are important in the cost management system. We talk about level of accuracy, that the something which we are establishing a cost management system, so we have to adopt some kind of level of accuracy, the unit of measure, where we have to keep the control accounts, what are our threshold, at what percentage deviation it is the time to take actions as such, and then how we're going to measure the performance, in what are all the information which we need to put into the report, and what will be the format of reporting, or the complete process of estimating, budgeting, and controlling the project. The first step in this direction is estimating the project cost. As we discussed, that we have learned about already what is the expert judgment, analogous estimate, parametric estimate, bottom-up estimate, three-point estimates in time management. It is same here also in with respect to cost. The reserve analysis a little different. There we talk about reserve in terms of duration. Here we are talking about reserves in terms of cost, and especially we are talking about two kinds of reserve: the management reserve and the contingency reserve. So welcome, Abda. We're just carrying on from where we left. So I'm just recapping what we discussed in the last session. So reserve analysis with respect to contingency reserve and the management reserve. We discussed that the contingency reserve is for identified risk, and management reserve is for unidentified risk, plus the risk which that may not solely for this project, probably at a higher level. So such kind of things are taken care of by management reserve. We also talk about that when we are costing the project, we must include the cost of the quality. So in the quality, we will learn how we arrive on the cost of quality, but all the quality activities require some investment, and we should have provisions for that. So therefore, the cost of quality should also be included. Vendor bid analysis, we discussed about that we can call vendors. When we get the bids from the vendors, we can analyze what are their approach and what is the quote, and then come out a tentative or more firm costing of the project based on what vendors bid for this project. Often more than one people are involved in cost estimating, and therefore the group decision making techniques could be useful here. What is an output come out here as an activity cost estimate? That is the cost estimate of each and every activity, and the documentary proof for proving our estimates or supporting our estimates. We discussed about the type of estimates. That is, one is the rough order of magnitude, that is plus minus 50%. The accuracy is low. It is normally done at a very initiation level of the project. Budget estimate, when we are having a better plan in our hand, that is goes minus 10% to plus 25%. And third type of estimates are definitive estimates, which are varying from plus minus 10%, which are normally when we have a very concrete plan in our hand, or we know quite a good information about the project. We talk about direct cost and indirect cost. Any cost which is directly billed to the project is a direct cost, and in any cost which come as an overhead to the project is an indirect cost. For example, if we are conducting a training, if the training is a sole requirement of the project, then the cost will go to the project, could directly go to the project, and it will be called direct cost. And when the training is generic in terms for improving the overall skill of all the employees, then a factor of that training cost will also come to your project as an overhead, and then it is called indirect cost. We also talk about variable cost and fixed cost. The fixed costs are normally invested in infrastructure, setup, etc. when we purchase some assets, and this cost cannot be changed later once incurred. While the variable cost is normally in the hand of the project manager, you can have a control on that. You can manage that variable cost. For example, resource cost. So if the project manager reduces the number of resources on the project, the cost comes down, and increase the number of resources in the project, the cost varies, and this can be done anytime in the project, and therefore it is called variable cost. So it is the variable cost which is mainly in the hand of the project manager and can be optimized.
Yeah, Vivek, this is Amitabh here.
Yes, Amitabh.
Yeah, actually, in the previous slide, can you can you again explain that I have the difference between this rough order magnitude, budget estimate, and definitive estimate. What is
see
how we can?
This is done at a very initiation level.
Correct.
Because the information is low, because very basic information is available, therefore your estimates are less accurate, and they are normally called rough order of magnitude. When you have concrete information in hand and you have done some kind of planning, etc., then you can, what the estimates you have, they are better, the accuracy is better, and they varies somewhat between minus 10 to 25%. It's a guide actually, so it's not a very hard and fast rule, but it's a guide that it's something that of that sort happens. And definite estimates are when you are actually start executing, or when you have a very concrete plan in your hand. When you have a very concrete plan, or you have started some execution, you have very good information in your hand. In that case, your estimates are definitely more accurate, and these are called definitive estimates.
Okay.
Does that make sense?
So only thing between the budget estimate and definitive estimate is Basically, budget estimate is when you are in planning stage. Definitive is when you are more into execution and you have more concrete information.
Yeah, actually the definitive estimates can also be the planning stage, but some kind of execution is being done. You have got more information, like if some requirements are done. So you have better information that may still be in the planning stage. Maybe budget estimates are a very initial level of planning, and while the definitive estimates are a matured state of the planning.
Okay.
The requirement gathering and scoping all are also part of the planning. We must understand that way also.
So exactly like when we any project get initiated, so very beginning we'll get some the statement of work and all. There is not much clarity, but still the project manager, they want to enter the estimates. So they'll come us and ask for, okay, give me your rough estimate, order of magnitude, which we can put, and this not hard and fast. Just we can, I can understand it can be 50% plus or minus. Okay. Then after that, when it proceeds and when we get the like SRBR kind of thing, which is materialized, so so especially not BR, we can more than that SR. So where we get the some clarity. That's now we have the understanding. So what it will go. So that's the place where we create the budgeted estimate. From the further, if SR is totally baseline, and when we are in the almost in the process of making of high level design kind of, then that's the place where we can give the definite estimate, where we have the more clarity. But what I told you, that is more roughly in terms of IT only, and almost same goes with other industry as well.
Yeah, basically the rough order of magnitude are ballpark figures, very budgetary figures. Okay, we have to allocate some budget. What do you think? How much budget should be allocated for this project? It's a very initial level. At a very high level, some money is to be secured for this project. Therefore, then such estimates, the rough order of magnitude estimates are normally done.
A definite estimate is the place almost by that time it get locked. So almost from there we see most of the time 5 to 10% of variance. Otherwise, it understood that the whatever given in the definite estimates is should be the actual budget for the project.
Fantastic. Thanks, Rajesh.
Thank you.
Okay, so the next stage is estimating the cost. Sorry, next stage is about budgeting, determining the budget, creating the budget. As I said, the time phase expenses on the projects are budget. So time phased distribution of the allocated money is budget. So budget, normally we have to, what we need to do, we do a cost aggregation. That is, from the previous step, we come out with the activity risk cost estimate. Means we got the cost estimate of each and every activity. Therefore, it is time to now aggregate. So aggregation means we sum up all the activities. We sum up all the cost of each individual activities and start summing up at a higher level, work package level, then in the higher level of the work breakdown structure. Then at a strategic place, we keep some control accounts so that segment can be, the cost of that segment can be measured separately. Something like that. I think this includes this also. Something like this. So this control account will take care of this branch of the cost of this branch. When we sum it up, it will call project estimates. We add the contingency reserve, which we have, this reserve we have kept for to mitigate or to respond to the risk. Then what we get is the cost baseline. Now above to this, there is some management reserve also, with a factor of management reserve get reflected in the project budget, and therefore the final project budget actually the cost baseline plus the factor of the management reserve, because normally management reserve is for multiple projects or at a unit level or at a department level, not at the project level. So a factor of that is actually coming to project budget. But what the project manager has to track is the cost baseline. not the final project budget. That could be for the management.
So what is the basic difference? Contingency and management reserve, Vivek?
So the contingency reserve is for the risk you have identified. Okay, to respond to those risks, the cost of response to those risks.
Okay.
Not cost of the response, but if the response plan fails, then how to compensate the losses. That is contingency reserve. So I have a mitigation plan, but mitigation plan does not mitigate the complete risk. I still have some money to, I still cannot achieve, like completely mitigate the risk. Therefore, some losses my project will suffer, and that losses will be compensated by contingency reserve. While the management reserve is for the bigger risk. As I said, like disaster management kind of stuff is not done at a project level, but at a unit, department, or the organization level. But this, every project get a factor of that budget, that cost into their budget.
Okay, but the disaster is coming, so it will impact all the projects in a particular moment.
Absolutely.
So it will get distributed to accordingly as per the CR.
Yeah, so because disaster is not going to impact only this project, but the other projects as well.
Correct.
This budget, this reserve is kept at a department, unit, or organization level, not at the project level. But if the department has 10 projects, then this reserve will get divided into 10, and every project will get 1/10 of that as a project budget, right? It will get added to the project budget.
Okay.
It's like that. Okay, once we get this aggregation, we take the schedule of the project also, and then start planning how the money will get, how this total cost will be spent on the project. Right, and then what we come out is called project budget, and it is called project baseline. So let me go to that place. This is how it is. So how we have got this cost baseline, because we have several activities planned. Like here we have started some initiation activity, let's say initiation activity, then some planning activity started, and some other activity also here. Then the project execution started, right? Many other activities start coming up, and multiple activities will come, right, during execution. And because of these activities coming and multiple activities will come, what you see that initially our resource level is less, the number of resources are less. Then as the number of activity increase, the resource level increases, right? And then as we move into execution, the more resource come into picture. Then we get even more resource come into picture. Right, and then as the project come to finish, we start reducing the manpower. Correct? Now, so these are because of the various activities. In end, there will be one or two activity with the one or two people on board. So how this line is sketched is that here the cost is this much only. So this resources. Now by this time, the resource this plus this, we get this. Then this plus this, we get this. This plus this plus this, we get this. This plus this plus this, we get this. Now it will start reducing, so it will come over here. And then it goes further reduced, it come over here. So my plan actually get created like this. And this is called project budget. It's a time phased cost of the project. So with this, at any point of time, like at the end of the 4th month, what the cost I supposed to spend? I supposed to spend cost this much. And if I may spend less or I may spend more. So this help us to track the overall project cost till at any point of time, and therefore this when we freeze this, when we finalize this is also called cost baseline. It normally come in the shape of S, and therefore called it is S curve. This is called project budget and called project baseline and also called performance measurement baseline, PMB. Now based on this, you announce your project funding, what time you need various funding. So in manufacturing and construction projects, a lot of procurement happens, so you need funding from the account, and based on this you forecast that when you need funding from the accounts for purchasing the raw material or other equipments or other parts of the project. And the same time the fund limit reconciliation also come into picture, where the accounts see that what was your forecast and how much you are withdrawing, and you may face a problem if you try to withdraw more. Now you have estimated, now you have put the budget in place, you have a cost baseline. It is time to control the cost when the project is in the execution. So mainly in the cost control we use earned value management, and let's understand what earned value management. So this forecasting, to complete, performance reviews are all part of earned value management. We'll see that what is earned value management and how it is implemented. As an outcome, or for all control process, you get work performance information, plan versus actual, the cost forecast. Earned value management also gives us schedule forecast that we saw in our time management thing. There was the schedule forecast was one of the output that is also come from earned value management. And the change request if we see the variance. So what is earned value? In the earned value there are three things. There are three measurements, only three measurements, which help us to understand our cost and schedule performance and forecast for the same. So understanding these three terms are important. And to understand this, let's see there is a project. This is a project of 10 days. The total cost of the project is $100. Okay. Now this $100 are distributed equally throughout the project. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So it is equally distributed. Suppose I am halfway in the project. So what is the total budget of the project? $100. What is the duration of the project? 10 days. I am executing the project and I am in the halfway on the 5th day, I say. With respect to time, I am on the 5th day of the project. 5th day is completed. What is the status of the project? So first we talk about planned value. What is planned value here? How much is the
50?
$50? Exactly. So plan 50 because 5 days plan, 5 days, 5 days plan should be there, and 5 days cost us $50, right? So what is the thing about the unvalue management is that everything, either plan, execute or actual, it converts into dollar and then compare. So when we say how much is the plan, I will not say 5-day plan or 50%. I will say plan of $50. On 5th day, what was the planned value? The value of the planned work. How much work was planned for 5 days, and what is the value? It is $50. Now, if I say,
We'll talk.
Yes.
Yeah. So we'll talk in terms of dollar.
Yes.
In terms of value.
You will talk in terms of dollar. Only one
Okay.
unit, and that unit is dollar.
Okay.
Or whatever currency you have.
Yeah.
But we will talk in terms of money. Now suppose I say you are 40% complete. So how much I have earned? In 5 days, 4 days of the work is earned, because how much is the total days? 10 days. 40% complete means 4 days of work is complete, right? That is my earned. How much I earned? 4 days of work. What is the value of 4 days of work?
40.
$40. So my earned value is $40. The planned value of the work achieved. The planned value of the work achieved. So how much work is achieved? 4 days. What was the planned value of 4 days? $40. And the actual cost is very simple, that what amount I have spent as of now. The hard cash, how much hard cash I have put into my project, irrespective of what was planned and what was achieved. So if I say I have spent $60 as of now, then I say $60 is the actual cost.
So here we are talking about the actual what we spent.
Exactly, actual.
So as per plan, it's supposed to, half of the work is supposed to go $50. That is the plan value. But we completed the work which we completed, that is only 40% of work completed. So that 40% of work is actually converted to in value, the earned value is $40.
Yes.
But when we go and actual check the finance, so I found actually we have spent $60.
Exactly. Now, so planned value is the value of the work which was planned till that day. Which day? The day I am measuring the progress. So I am measuring the progress after 5 days. So how much work was planned? 5 days work planned. What is the value of planned value of the 5 days work? Is $50. At that time I see how much I have achieved. I say I have achieved only 40%. 40% is equivalent to 4 days. What is the planned value of the 4 days? $40. So my earned value is $40. How much really I have spent? I say I have so far spent $60. So I put as a $60. This is the real money which I have really spent on that. So what is the status? After spending $60 after 5th day, I have achieved 40%, $40 worth of work. $40 worth of work I have achieved. Now let's look at the other terms. What is budget at completion? Budget at completion is the total budget of the project. Total budget of the project. Total budget of the project is how much? $100, right. Now other terms come at estimate at completion. You see, I am not going as per plan, right? On 5th day I am seeing I have spent $60 and achieved only 40%. That means I am not going as per plan. Therefore, estimate at completion will be different than budget at completion.
Correct.
How much is that? We will calculate it. Estimate at completion. What is the difference between estimate at completion and estimate to completion? Estimate at completion means the total cost of the project, new estimate of the total cost of the project. So total new estimate. The estimate of the total project. And estimate to complete means from this date to the remaining time. So from this place, how much more money I will spend, from this date. Therefore, EAC is equal to estimate, this estimate plus AC, actual cost. So this is actual cost and this is ETC. So AC plus ETC is equal to EAC. Does that make sense? Either I can say it is ETC plus AC is equal to EAC, or I can say ETC is equal to EAC minus AC.
Minus AC.
Right?
Yeah.
What is BAC? VAC is variance at completion, the difference between BAC and EAC. So BAC minus EAC. That is the variance. This was originally budgeted. This is what the new cost which has come out because of my not going as per the plan, and that is the difference. That is the difference means that is how much I more or less I will spend against the budget. Now let's look at the schedule, how we calculate schedule, cost variance, cost performance index, schedule performance index, to complete performance index, and the estimate. So it is very simple. Schedule variance is earned value minus planned value. Earned value minus planned value. If it is 0, on plan. If it is plus value, very good. If it is minus value, not good. Minus value means we are behind schedule. Plus value means we are ahead of schedule. 0 means we are on schedule. Similarly, cost variance. EV minus AC. Earned value minus actual cost is the cost variance. If it is 0, I am on budget. If it is plus, I am under budget. If it is minus, I am over budget. Minus means I have spent more. Plus means I have spent less than expected. And 0 means I am spending as expected. Similarly, we say at what rate we are going. You or follow cricket, we say what is the run rate. So this is the schedule run rate. This is the schedule run rate. Schedule performance index is what rate the schedule is being achieved. It is nothing but, here it is minus, here it is division, EV divided by PV. If it is 1, it is neutral. If it is more than 1, it is good. If it is less than 1, it is bad. Similarly here, more than 1, good, 1, neutral, and less than 1, bad. So CPI, if cost performance index is less than 1, that means I am spending more money to achieve less. Every dollar suppose CPI come 0.9, that means if I spend $1, I get the work done of 90 cents only. If it is 0.6, then it means every dollar I spend, I get work done of 60 cent only. So ROI is 60%. Similarly, SPI, if SPI is 0.9, that means I am running behind, but I have achieved only 90% of the schedule which I targeted. You all follow cricket? There is something called run rate and there is something called asking run rate, right? So TCPI is nothing but the asking run rate. I mean to say, at what rate should I now move so that I complete the project within budget or on time? It is TCPI, it is calling about budget. So EVM is more focused on cost than schedule. It does talk about schedule, but it is not so accurate or it's not so focused on. So TCPI is at what rate I should go now so that I complete the project in budget. That means the remaining work, BAC minus EV, this much is achieved and this much was total. So this is the remaining work divided by remaining money. So if I divide remaining work divide remaining work by remaining dollars or remaining money, I will get TCPI, that is the asking run rate, asking rate of expense. So if it is 0.9, the CPI, it will maybe, so CPI is less than 1, indicate that TCPI will be greater than 1. If CPI is greater than 1, says that TCPI should be less than 1. As you see here, ATC is EAC minus AC. Is that all clear? Let me calculate also. EV, how much EV? 40. How much? 50. So this is minus 10. How much EV? 40 minus 60 minus 20. This is 40 divided by 50. How much is that? 0.8, correct? This is 40 divided by 60. It is 0.66. Right? We can calculate this also. BAC was 100 minus EV 40 is equal to 60 divided by 100 minus 60, 40. So it will be 1.5. So this TCPI is 1.5. For every dollar I spend, I should get the work done of $1.5. Only then I can achieve the project within budget. Now this is EAC minus AC. But how to calculate EAC? There are three ways to calculate EAC. There are three ways to calculate EAC. How is that? AC plus bottom of ETC. When original estimates are fundamentally flawed, means my estimate after executing for 5 days, I come to know that whatever estimates I did were totally wrong. My variance is okay. I decided to re-estimate the remaining work. When I re-estimate the remaining work, my AC will not go anywhere. So whatever my re-estimation, so this is becomes AC plus re-estimation. And re-estimation of remaining work, that is called ETC. Estimate to complete. From this point, how much it will take to complete the project. Second is BAC upon CPI means I am running at this rate and I continue running on this rate. Whatever the problems or whatever the issues are there in the project will continue be there. I continue at the rate. I am running at a rate of 0.9. My CPI is 0.9. I will continue running at this rate. And therefore my BAC will be factored by my CPI because that's my rate. How much I will get? So my BAC is factored by CPI. That means it come out to be almost 111, something like 110 or 11. Okay, so my EAC will become in this case 111. In this case I cannot determine, it depend upon the re-estimation. But in this case EAC I can determine that my cost will be more because I'm running slow. Now the third situation. So there are various situations and therefore EAC will be calculated differently. The third situation is that though the variance was there today, so this was my baseline. I deviated like this, but from here I will go exactly the way it was. So wherever if that was the variance, it will be the same variance at the end of the project. So there were problems, there were teething troubles, we can say there were some problems so far, but now those problems are overcome. We will not going to face any problems. So remaining work will be done in the remaining estimates. Remaining work, so if how much is the work done so far? 100 minus EV is the work left, that is 40. So $60 work is left. That will happen in $60. So far it was 5 days work which was done in $60. The 4 days work was done in $60, but now the $60 work is left which will be done again in $60. So how much is my EAC? 60 plus 60 is equal to 120. And you calculate VAC. In this case it is 100, it is 11. In the other case it is 20. Basically minus 11 and minus 20. Is that clear?
In last Vivek, last case,
last one,
you have completed.
Last one is like that. That my baseline is like that, but I faced the problem in the beginning. So instead of going on this line, I went like this. But now I see till this date there were some problems. So I deviated from line. But now I will not deviate. I will go exactly parallel to this. So this work was before this line, the $40 work is done. How much I spent? $60.
$60.
How much work is left? $60.
$60.
I am saying those problems will not occur anymore. So $60 work will be done in $60 on estimate. Whatever work is left will be done as per the estimates.
Okay, as per the estimate.
As per the estimate of the remaining work. Yes, remaining work.
Remaining, so remaining we have 40 only.
No, remaining is 60. 40 is done.
No, but we have spent $60.
We spent $60, but work done was only $40 work.
Okay.
So how much
So remaining work is left for the value of $60.
Yes, 4 days work is done, right?
Correct.
6 days work is left.
Correct.
6 days work left means how much worth of work left? $60 worth of work left actually, right?
Correct. Correct.
And we are saying now that those problems will not come, it means I will achieve this work in $60 only.
Okay.
But as of now, I have spent $60. Therefore, I have bought this AC. So AC so far is $60 plus BAC minus EV is $60 here. 100 minus 40 come out to be 120.
So estimated completion will be 120.
Right. So EAC will be 180. Total the estimated completion will be 120.
120.
Make sense?
Yeah.
All understood? Let me repeat this once again. You see this is a cost baseline. Okay, this is what we have planned. At one point of time, we decided to measure the performance and we found that we are spending more than the baseline. We also found that we have earned less than the baseline. This much supposed to be earned and this much supposed to be spent. But we earned less and spent more. Right? Is that clear? This is schedule variance. We supposed to achieve this much, but we achieve this much. This difference is schedule variance. This is cost variance. We achieve this much. Therefore, we should spend only this much, but we spend this much. So this difference is cost variance. So there is a question for you. Let's try out this method on this. This is a very simple example. What is here is a project comprising of 4 modules is to develop. Each module takes 1 month to develop with estimated budget of $5,000. So every module takes $5,000. Modules are planned to develop in sequence. The status of the project at the end of 3rd month is presented below. So there are 4 modules. Each module costs $5,000 and these modules to be done in sequence. So like module 1, then module 2, then module 3, then module 4. What is the we are taking the measurement at this point, right? 3rd month, at the end of 3rd month. What is the status? He says module 1 started on time and finishes on time. It is completed. The status is completed. We spent $5,000 as scheduled. So the same, there is no deviation. But the module 2 started on time but finished later. But as of today, it is complete. But we spent $6,000. Because module 2 finishes later, therefore the module 3 start late, and as of today it only 50% done, half done, 50% done, and so far we have spent $3,000. You need to calculate all those values we have just talked about. You need to fill this table. Can you tell me how much is the PV?
Plan 15,000 and earn is 5, 5, 10 and
15 and actual cost is 14.
Earned is
13,000.
how much?
13,000.
13,000. How come?
5 plus 5 plus 3.
Why? How this 5 plus 5 plus 3?
first completed is 5,000.
Yes.
Okay. Second module completed again 5,000.
Okay.
And third module only 50% completed.
Yes. So how much?
So 13,000.
Second module took 6,000.
The cost incurred which is shown in the last column is actual cost, is not the planned cost.
Yeah. No. What?
How much is AC?
talking-
How much is AC?
AC is 14,000.
AC is 14,000,
14,000.
right?
Right.
Then how much is the EV? How much we have earned so far? 2.5, right?
2.5.
Correct?
Yeah.
What is the planned value of 2.5?
Plant value of 12,500.
12,500, right? Half done means 2,500.
Yeah.
What is BAC? Budgeted completion?
$20,000.
20,000. There are 4 modules to be completed. The total cost of the project is 20,000.
20,000.
Can you fill this now? First 4 columns I have helped you to conclude.
So,
Sorry. Check out with this. Let me know if you see any challenge in understanding this calculation. All got? Or any challenge?
EAC.
Yes.
So EAC is actual plus BAC minus earned value.
EAC,
Actual plus BAC minus earned value.
yeah, but is that mentioned there? That whatever we have is there, we will complete this in the remaining budget.
Okay, no.
If somebody has reported you performance and didn't tell anything, what do you guess? I agree that nothing is mentioned about which condition we should apply for EAC.
Mm-hmm.
But if nothing is reported, what should I assume actually? You will continue the same way.
Okay. So we'll assume that it later portion of the work will go properly.
Yeah, until unless somebody says that.
Okay.
If
So
nothing is
that
mentioned,
formula applies only.
nothing is mentioned, I assumed that he will continue at the same rate as he is going.
In this case, BAC divides CPI.
The second formula.
Okay.
Because nothing is mentioned, either we are re-estimating or we will complete the remaining work in the estimated cost. Nothing is mentioned, so I assume that whatever the rate whatever the problems or whatever the things are there, they will continue to be there.
So BAC is 20,000 and the rate what we are proceeding is 0.893.
Yes.
So that is what divided. Okay. Yeah. The estimate to completion, that is we got the EAC, then EAC minus actual EV.
Yes. All good? Should we move on?
And VAC again, we are considering we'll go the same rate.
Sorry?
For VAC?
VAC. This one?
Yeah.
So VAC
Last one?
minus EAC.
Yeah. Okay.
The originally estimated plus the new estimate.
Okay. VAC minus, okay, EAC. Yeah, it's clear.
So this way you can do forecasting. You can do forecasting with respect to rate, that is TCPI. You can report the variance in schedule and cost. Schedule variance will be reported in time management and cost variance here. You can do performance analysis, variance analysis. You can also do trend analysis with respect to like CPI, SPI, that how SPI is going up, down. So over a period of time, you can see the trend. What is the trend? And you can keep doing reserve analysis, that how much reserve is left. As an output, you report what is your schedule variance, cost variance, cost performance index, schedule performance index, EAC, VAC, etc. And the budget forecast. You might have seen this in both the chapters, that is the time management as well as the cost management. And if we having some kind of variance, then change request is inevitable, right? And this is how we normally control the cost. Go to our handouts, go to page number 295. Go to page number 295. And there are 15 questions on cost management. Let's attempt them. When you are done, please write this in the chat box and we can discuss them. Okay, so what about question number 1? All A, right? What about question number 2? Okay, what about question number 3? Good. All D. One C. Okay. The cost performance index of a project is 0.75. It means, okay, see, the thing is that when we say talk about cost performance index, it is about ROI, how much money we are spending and how much work getting done. So that means every dollar I spend, I complete the work of only 75 cents. So whatever the work is getting done is of only 75 cents if my CPI is 0.75. Now in terms of schedule, when say SPI, suppose SPI is 0.75, that means I am running at a rate of 75%. I supposed to achieve 10 tasks, I achieve only 7.7.5 tasks. So that is where we talk about 75%. But when we talk about cost, means the 75% of the cost. So every $1 we achieve only 75 cents worth of work only. So cost incurred as of now is 25% higher than planned. No, it is not right actually. One 25% of one is not same as 0.75% and 100. So D is actually the right answer. This is the right definition of CPI. Make sense? What about question number 4? All C? Okay. What about question number 5? Question number 5. What about you, Amitabh? Okay, this could be a little confusing as such. See what it says, this is a bit tricky also. The task was scheduled to use
Yes, I have a doubt as well. Yeah.
two full-time resources and estimated to take 2 weeks to complete. 2 resources for 2 weeks. So if I say what is BAC, it's come out to be a 4-person week of effort, right? 2 people for 2 weeks. Right now, at the start of the task, one resource got sick. Only one resource out of 2 could work on this task. So from very beginning, only one resource is working. At the end of 2 weeks, means actual efforts are 2-person week. At the end of 2 weeks, the assigned resource completed 75% of the task. How much was the task? 4% week worth of task was there. 75% of 4% week, that is earned value, right? Which is 3% week. So if I say what is your CPI is equal to 3 upon 2 is equal to 1.5.
Should be B.
It should be B. Right, so let's about question number 6. B, A, B. This is simple, right? In which project management process the estimates are rough order of magnitude? See, this is first step, initiation, then next step, then a step. Naturally, rough order of magnitude means it is a very like high level estimates, inaccurate basically. So inaccurate means it should be, as we move into the project, the estimates will get better and better. Isn't you think that it should be initiation? Rough order magnitude, and then budget estimate, and then definitive estimate. So rough order magnitude means very initial level. As we move into the project, the estimates get better and better because we know more about the project, right? So answer should be A in that case. It should be plus minus 50% rough order magnitude.
So initiation phase. What are you planning then?
The planning will be you have quite a good information with you. It could be either budget or could be definitive. If it is not definitive, it should be definitely budget, right? At the initiation only it is a rough order of magnitude. Even in planning, if you have a rough order of magnitude of estimate, then how do you plan?
Okay.
As a rough estimate,
No,
how do you plan with the rough estimates?
No, I took this way because all these processes comes in the planning phase. That's the reason I took this planning instead of initiation.
Okay, okay. But in the beginning, you might have seen that we talk about 3 estimates, right? Rough order of magnitude plus minus 50%, then budget estimate minus 10% to plus 25%, and then the definitive. So we said rough order magnitude is a very initial stage. Budget estimate, something like you have started planning, you have got some information, and definitive means you are quite a matured state of planning.
Yeah, no, we got your point. So you basically we are talking about the term, whatever you use your rough order of magnitude, not the process what we are talking about.
Yes.
Yeah. Okay, then it will be initiation. Correct.
What about question number 7? Okay, great. What about question number 8? All C. Great. What about question number 9? This is a bit calculative, right? The answer is right. What about 10? That's great. B, great. Going good.
I think Amitav, is he completed also as well?
Amitabh? Not hearing from him.
Oh, he is facing some link problem. I
Yeah,
think
but
he was written somewhere.
he's live actually. He's not offline. He's online.
Okay, so I think he is not able to hear.
Not sure if he's speaking, but
Link problem, not able to.
on mute.
Okay.
Yes, Amitabh is there, very much there. 11C, right? All C? What about 12? Okay. Getting line on and off. Okay. What about 13 then? This is going great. C, 13C. Project cost control include all of the following except C, aggregating the cost, estimated cost of the individual activity of the work package is a budgeting exercise. Taking corrective action is a control. Right? We see corrective preventive change request is only in the control. Aggregating the budgeted cost is basically a budgeting exercise, not a part of the cost control. So therefore, D is the right answer. What about 14? Yeah, on the on the face value it looks like C, but basically what is parametric estimate? There are two things. One is the parametric estimates are basically about, first is formula and second is
Historic.
estimate, like reading or analyzing many previously done projects and then working out a trend to find out that how the new project should be estimated, which is actually this. These two things matches, therefore it looks like on the face value this is, but actually it is the uses the statistical relationship between historical data and the other variables to estimate activity. We talked about this in the last chapter, that is the time management.
Yeah.
Right, so A is the right answer. What about 15? A, C, D. Okay. Determine budget including all of the following except. So what is A? Ensuring baseline includes all authorized budget except management reserve. That we saw that up to contingency reserve and things. So A is very much part of the budgeting. Aggregate cost of the individual activity or work package to establish a cost baseline. That was also there, right? The first exercise was aggregating and then establishing a cost baseline based on the schedule, right? C is developing approximation of monetary resources. What is developing of approximation of monetary resources? That is basically an estimation, right? Doing reserve analysis and establishing contingency and management reserve is also part of the budgeting. Developing approximation, the definitions, you look at the text is very confusing. Developing approximation of monetary resources, basically estimation, to describe this estimation. Make sense?
So should be C?
Yes, it is C. Yes, it is C.
Okay.
Okay, so it is around 8:50 in my 55 as such, going to 55, but can we come back by 9:20? Will that be fine? Can we resume at 9:20?
Right.
Okay, so let's resume at 9:20, and if possible, if not possible, let me know. We can start at 9:25 also. In 5 minutes, nothing great happening as such. You need explanation on question number 5, right?
Yeah, question number 5. Yeah.
See, it is like that. It says 2 full-time resources estimated to take 2 weeks, right? So 2 into 2 is equal to 4% week of effort, right?
Correct.
This is our BAC. That is what is required, correct?
Correct.
Now at the start of the task, one resource got sick and only one resource could work on this task. At the end of 2 weeks, the assigned resource completed 75% of the task. What is the CPI? So how much efforts actually put in? How much efforts actually gone into? 2%.
So only for one resource, correct?
One person worked for 2 weeks, right?
Correct. To 2%.
Right. And what is EV? EV is 75% of the work.
Correct.
Correct? And how much is the work? 4% week.
Correct.
So EV is 75% of 4% week, which is 3% week, right?
Okay.
So CPI is 3 upon 2 is equal to 1.5.
Okay.
Right?
Okay, fine. Thank you. Yeah, fine. Thank you.
Okay, the process here, the quality policy, objective and responsibility. So what here is, when the term policy come into picture, people often think it is an organization policy. The project policy can be different than organization policy, probably 90% same, but the 10% it can differ. Maybe when you're developing quality policy for the project, you can inherit the organization policy and then make appropriate changes as required by your project. So that is forming the quality policy, setting out the objectives of the quality objectives, assigning roles and responsibilities for taking care of the quality objectives, and ensuring that we are meeting those objectives is what quality management is all about. Right? If I ask you what is quality, can you tell me what is quality? So what is quality? What do you think quality is?
It is something which met, say, the product or something, product or the final service which meets some criteria which we have defined. Say we have some defined criteria. So if the final service or the product meets those things, then we say, and it meets that particular, it meets the quality standard of that.
Okay. Any other?
Quality is you deliver what you say. It's actually the output that we have committed before the start of the project.
Met a standard what we have given for any particular product or services.
Right. Basically, quality is what quality is. When you deliver some product to somebody, what this person's expectations are and how much your product meet to those expectations. So when we talk about the other person's expectations, it talks about who has set those expectations, from where those expectations are coming. If I get a pen and give it to you and say, tell me the quality of this pen, it would be difficult unless I tell what kind of pen I am giving to you and what you should expect out of this. So 2-3 things are here. There are 2 things coming basically, the expectation of the receiver and how much product matching to those expectations. So first thing, from where those expectations come? From where those expectations come?
Stakeholder, vendors, stakeholders and vendors, project sponsor.
Okay, these are stakeholders, but from what they expect from the product, how they actually decide that the product should do this.
What are the deliverable steps for that project, or what are the end deliverables which the product is expected to provide?
Right. The thing is that what you have set the expectations. what expectations you have set, what you have committed in the beginning. You said, I'm going to give you a fountain pen, and you give a ball pen. We say, what you have given me. That's not the intended item, and therefore the quality is poor. I say, I will give you a pen which can write for let's say a 100-page book. But if it finishes in 70 pages, you say the quality is not good. But if I have not said you anything, then what about if I give you a pen and I didn't set any expectations to you? What do you expect from a pen then? Then you take a general perception. What is the perception in public? If you exceed that perception, your quality is good. If you cannot, your quality is bad, and you are at the mercy of the other person's perception. And that's where the quality actually is beaten up even after a lot of work is done, because you might have not set the expectations. So first thing is committing what you will deliver and delivering exactly that, no less and no more. Even more is also a problem. Many times we think more is okay, but more is also a problem. A little more may make a person happy, but more will not make the person happy. You committed that you would deliver the product in 6 months. You deliver in 5 months. What do you think? Your customer will be happy? What do you think? If 6-month project, you committed that you will deliver in 6 months. If you deliver in 5 months, will your customer be happy?
If it meets all the defined requirements and quality standards, then the customer will not mind.
Oh,
but he will not expect. I mean, it is an unnecessary thing to do. I mean, I think it's better to deliver in 6 months.
Exactly.
And he may not be happy also.
He may not happy. But 2
happy.
days in advance, he will be very happy. But he will you deliver 1 month in advance, he may not be happy.
Yeah.
Until unless you tell him that you are going to deliver a month in advance, well in advance. That is the quality. Because what I have committed, I have deviated significantly from there. Therefore, my quality is poor, either more or less. So I should deliver what I have committed. So first I should commit and then deliver as per my commitment. No more, no less. And that is quality. It contains 3 processes: plan quality management, perform quality assurance, and control. So this is part of the planning. This is part of planning. This is part of execution. And this is part of control. You know, we discuss about validate scope. And
are you sharing something?
Oh, sorry. Yes. 1 minute. I think. This is. So plan quality is part of planning. Perform quality assurance is part of execution, and quality control is control. You may remember there was a validate scope in the scope management. Validate scope has a input called verified deliverable. And then it's a accepted deliverable. What is this verified deliverable? This is an output of quality control. So, and the input is deliverable. A deliverable, which is an outcome of execution process, first goes to quality control, come out as a correct deliverable, checked for correctness, which is called verified deliverable, goes into validated scope and come out as correct and complete and accepted by customer or accepted by stakeholder. That is how the sequence is. It is implemented through quality policies, procedures, quality assurance and control activities, and quality is not a one-time job, it is a continuous process. Improvement is what is the need of to implement quality in the project. Now let's discuss about a couple of things. Do you understand what is the difference between quality and grade?
Grade is more
Quality
definitive.
which is given. Yeah, go ahead.
I think
Go ahead.
grade is more definitive. I mean, it's a measure of quality. So if I say this is a product which comes in two grade A, B, and C, but they are meeting their own quality standards. But the quality is an overall thing. I mean, I'm speaking very generally. May not be the exact definition.
Okay, Rajesh?
Yeah, quality exactly like grade is a standard, something which is given in the market standard and all. Based on that, whereas the grade also goes with the quality, but at the same time, if certain values below that, then we'll say that the grade is not good also. So based on the quality, they have some grade has been maintained.
In all three, this is the lowest grade and this is the highest grade. Quality of all three is equal.
Okay.
Richness of feature is great. High grade means more features. Quality means conformance to the expectation or the requirements. So Honda said its car will run for 5 lakhs kilometers. It should run for 5 lakhs kilometers without breaking down. That's quality. And richness, so all three will do the same thing, but or they can set the similar different quality standards for that. But grade is richness of the feature. What is quality assurance, quality control? Quality assurance happens when product is in process. This is in process of developing, and quality control happens after completion. This is proactive. This is reactive. Proactive means we are assuring that tomorrow the product which will come out will be of quality. Quality control is reactive, means the product has already come out. I'm saying that I'm checking if this product which has just come out is of quality or not. So in process, quality assurance. When it is delivered and now you are checking, it is quality control. What is precision and accuracy? Precision and accuracy is something like x is equal to 1.5342 is expected. You get two readings, 1.52, and second reading you get 1.49325. Which one is more precise?
A.
A is more precise?
Yep.
Okay. And which one is more accurate?
B1 is the accuracy.
Which is more near to x?
The A is more accurate while B is more precise.
B is more precise and A is more accurate because the difference between X and A is less comparing to X and B. But the depth of the B is much higher than A. If a scale can measure millimeter, it is precise. If it can measure the hundredth of the millimeter, it is even more precise. As the project scope and product scope come into picture, similarly come here as a product and project quality also. So what is product quality and what is project quality?
Product quality is about the quality of the and while the project is the process, the quality of the process, how the product has been made or how that has been executed.
Okay.
The overall process.
Okay. Which is right actually. The product is the quality of the outcome. And project is the quality of process. When I say number of defects in the product is a product quality. A schedule variance is a project quality. Cost variance is a project quality. If you deliver a very perfect product 10 days after the committed date, your project quality is poor, product quality is good. You deliver a substandard product on time, your project quality is good, your product quality is poor. If you deliver on time with lot of defects, your product quality is poor, project quality is good. Now what is the difference between conformance to the requirement and fitness to use? These two terms come in the quality. They are not same. Conformance to the requirement, I will say, think from this perspective. Normally, the vendor goes this way. It looks for conformance to the requirement. Why? The customer check for the fitness. Is the problem is solved or not? There is a fair possibility that conformance to the requirement is 100%, but still the outcome is not solving the purpose. This may happen because of poor requirement at customer side or vendor side. Customers are normally not very expert in the area. Therefore, there is a fair possibility they may not be able to narrate their requirements properly, what the thought is going into their mind. If the vendor, without challenging those thoughts, without challenging those words, do conform to the requirement, it may happen, it may be delivered, but customer may not use it because it may not solve the main purpose. The matrix.
Yeah,
Yes.
Like for example, let's say there is a software which does all what is required to do, but it is not user friendly.
Yes.
That could be an example of this.
That's absolutely true. If there are no, or whatever the user friendliness was specified, you have met that, and by meeting that also this is not user friendly because the requirements were so aligned with the the user's psychology, then it may not be very user friendly, and therefore people may not use it. It may not solve the purpose even though it conforms to the requirement. Absolutely right. What is the difference between metric and measurement? Metrics are measured. So when you prepare a quality plan, you identify metrics. When you do execution, you measure those metrics. In the planning, I decide I will track my schedule deviation. During execution, I see how much deviation is there. That is measured. We should remember quality is planned in, not inspected in. Means quality is a proactive approach, is a proactive item. It's not a reactive item. All quality activities should be planned in the schedule, in the plan. They should not be, you should not wait till the product come out and then you inspect it. Quality itself is a very big subject. So, and many things which are common in project and quality management. Not only these things, there are many more things are common. Like both look for customer satisfaction, both prefer prevention over inspection. Both feel that it is a management responsibility to deliver to the customer, and both are implemented through continuous improvement. There are many more things than this. What is cost of quality? The cost of quality is defined with two things. One is cost of conformance and second is cost of non-conformance. The cost of conformance divide into two portions. One is prevention cost, another is appraisal cost. Cost of non-conformance is divided into two kind of failure. Cost of non-conformance means you face a failure. It could be an internal failure, it could be an external failure. What is prevention? The steps, investment in the activities which can prevent the defects. Your planning is done. If you are a good planner, number of issues will be less, the number of defects will be less. You provide training to the resources, number of defects come down. You have a SOP, standard operating procedures, probably the number of issues will come down. You have automated tools and equipments, probably human errors will come down. So these are all preventive costs. Now the second thing come, you check. The checking is appraisal cost. It's not a cost of non-conformance. It's to ensure that cost. So you do audit, walkthrough, reviews, testing, inspections. All these are appraisal costs because we are appraising if the product is right or not. Cost of non-conformance with two failures, internal failures and external failure. If the project team identified the failure, it is internal failure. If the other than project team identifies, like customers, the management, the user identify the failure, the problem, the defect, it is an external failure. No need to say that external failure is normally more costly than internal failure. So testing is not cost of failure. Testing is a cost of appraisal, but because of testing some defects will come out. Those defects, repairing those defects is the cost of failure. If you prepare something and you have to scrap it, this is the cost of failure. If you have done something but it is not done properly, you are reworking on it, it is the cost of failure. Rejects, complaints, they are all cost of failures. Business loss. Now there are 7 basic quality tools. They are implemented in many projects, especially in manufacturing segment. I think almost all are used, but in IT there are some selectives are used. But they all are quite important and they can be used in various situations. We will use these 7 basic quality tools for planning, for assurance and for control, all 3. And therefore I just take you through these 7 quality tools and then we can talk about planning, execution and control. So what are these basic quality tools? What is cause and effect diagram? Anybody has an idea? Anybody has an idea? Yes.
It is a diagram which shows what are the various causes, and it is a diagram which basically shows what are the causes, and because of these reasons what are the effect which can have on the project, say, or whatever outcome.
What is the problem?
So we identify what is the problem, that is the effect, and what are the causes for that problem.
Right, absolutely.
Causes.
Root causes of the problem. It is used to identify root cause of the problem. It is also called fishbone diagram and Ishikawa diagram. What about flowcharts? We just talk about SOP, process. So flowchart are easy to understand. You define, easy to define and easy to understand. You define process, SOPs and other things. It help us to understand or disperse the information to the people and explain them properly. Flowchart helps in clarity and therefore less issues. What are the checklist? Check sheets? Anybody has any idea what is check sheets?
Prepare the item which has to be completed and check against that whether all the item has been completed or not.
Okay.
List of items and
okay. Check sheet basically used to identify that how many times a problem is occurring. Okay. Let me take you one by one. So cause and effect diagram is like this. We have a problem and we are trying to identify what is the root cause of. So there are sub branches. This is the main branch, there is sub branches and then sub. You can do it further also. Self review not done. Why self review is not done? So normally there is a lean principle called 5Y. Why can be implemented using this. 5Y normally help us to understand the root cause of the problem. Okay, it is because it looks like a fishbone. It is also called fishbone diagram because it is invented by Ishikawa. It is also called Ishikawa diagram. This is the Excel implementation of root and cause and effect diagram, or say 5Y. So you say there is no computerization or there is no computerized solution to handle job. So why it was happened? There was a staff resistance. Why the staff resistance? They are not explained and full benefits. They feared being made redundant, and they are uncomfortable about changing the way of work. Then we again go to another why. Why the benefits are not explained? We say there is a lack of communication. Why they fear? They thought the computer system are designed to replace them. Why they are not so comfortable? They had always been doing it this way, so they are comfortable with that. The positive aspects are not communicated of the changed way. This way you reach to the benefit and you come out with the root cause, that what is the root cause of these things, and then you can act on it. So this is one way of implementing fishbone diagram. A flowchart is normally, you might have drawn various for process flowgram, data flow and process charts. So flowchart is basically to explain the process and understand it well. Like this is one of the example of showing the whole process of how a software code can be written and can be tested, and any problems come, then how it can be fixed. So this get a lot of clarity to everyone that what is their scope and what they're supposed to do in the whole process. What is check sheet? Check sheet looks like this. Check sheet looks like this. You say it is counting that what is the problem coming. So number of defects, if I say, then it is a missing paperwork. So day 1 there were 5 such incidences, day 2 there are 3 incidences, day 4 there are about 10 incidences. Damaged packaging. Day 1 incidence, day 2 incidences, day 5 incidences, day 3 and 4 no incidences. This way we calculate that what kind of issues are coming and what is their frequency of coming. Right? This way we figure it out which type of issues are more, which type of issues are less. This is the check sheet. And when you use the check sheet, you come to know about the various issues or various defects which are coming and how many numbers they are coming. Say the highest number is missing paperwork, the second highest is missing part, the third highest is damaged packaging. There could be many more defects like that. Once we have this, we use Pareto chart. What is Pareto chart? Pareto chart is about 80-20. You say your 80% of the problems are because of the 20% of the reasons. So like here we figured out which defect is coming in more numbers, and then less numbers, and then less numbers. So what Pareto chart says, that you put the defects in the descending order of their frequency. In the descending order of the frequency. So maximum number of frequency of A, because A has the maximum number of frequency, it is first, then B, then C, then D, then E. So in the previous example, if I say missing paperwork is A, which is the highest frequency, then missing part is B, because this is the next highest frequency, and then the other things. How we find which 80%, which 20% actually causing our 80% of the problem? You see, this we create a cumulative graph. So here this is this plus this, this is this plus this plus this. So we created a cumulative graph. We come over here, the top of the graph is 100%. We come to the 80% and drop a line on this and then drop a line on this. It shows that your 20% of the reason are this A and B, which are causing 80% of the problems. So 80% of the problems are because of A and B. So if you can attack A and B, your 80% of the problem will go away. So that is the Pareto chart. Pareto chart will tell us where we have to focus. What is our 20% which is actually impacting our 80%, and therefore let's attack this 20%. Then the histogram. It's the most common graph which you might have used. Plan versus actual. So this is plan, this is actual. So plan versus actual, histogram comparison between two things is normally used. The histogram is normally used to compare the two things. Then comes to control chart. What is control chart? Control chart is to establish the capability of, or to check, the capability of the process. It is used to check, every time checking the capability of the process. So now suppose you are building lot of packages, right? You are coming out with the packets. So packets of anything you are developing. Every time packets come, it fall somewhere on this control chart. You might have seen that on the various like food items, the batch number is given. So every time batch is prepared for like a like say a health tonic or anything which is powder. So they are mix of various things. So they mix together, one batch is created. This batch goes first for testing and then only packaged, or if packaged, it is sold only if the testing is passed. So every time you test that batch, every time you prepared a batch and you test it in the quality lab, you put a point on control chart. This is mean. In the control chart, this is mean of the points. So it may keep moving based on where the point is coming. There is a lower specification limit, there is an upper specification limit. So what is lower specification limit and upper specification limit? The specification limits are the limits which are given to us. Like customer gave us that he cannot tolerate anything beyond this limit. To honor that limit, we put a control limit. So we have put a control limit which is little narrower than the specification limit, so that we can keep the process within these limits, so that it never exceeds the customer specifications. So we keep the control limit such that it never exceeds the specification limit, and then start drawing our chart. Every time testing happens, a point come on that. The basic thing about the control chart is that every dot should come on the chart should be random. Random is the randomness is the key of the control chart. Randomness should not be lost at any point of time. It is lost, then it's an indication of some problem. Problem may or may not happen, but it is an indication of a problem. So there is a rule of 7. What is the rule of 7? If there are 7 continuous points on one side of the mean. So there are 7 points, all 7 points continuously on one side of the mean. It is indicating a problem. 7 points on this side of the mean can also indicate the point. 7 continuous point raising or 7 continuous point declining. It could be they are indicative of problem. 7 continuous point hugging the any line, 7 continuous point hugging the line. They are very near to one line, any of these lines. Then it could be a problem. Any single point, not 7, any single point out of control line indicate that process is out of control. So there are two things. One is rule of 7 and rule of out of control line. So out of control line, even a single point goes, we say process is out of control. If 7 continuous points are either one side of the mean, hugging the control limits, 7 continuous point rising or declining, they all indicate that process is probably out of control. Process is out of control, and therefore it's a need to investigate into the matter. Randomness should not be lost. So 7 or more continuous point on one side, 7 more continuous point raising or falling, 7 points hugging any line, or some pattern coming again and again. Suppose this, then after some time, then again come here, then again sometime, again come here. If that happens, then it is again loss of randomness and therefore could indicate that the process is out of control. Or any point goes beyond the control limit, is a process is out of control. Is that clear? The seventh one is the scatter diagram. What is a scatter diagram? Scatter diagram I showed you in the morning also, or in our regression analysis. The scatter diagram normally establish the relationship between two variables, and it depends upon how the trends are. So whatever the historical data is available, you based on historical data, you sketch a graph between x and y, or between any two variables, and see that when x increases, how y behaves. So in this, y is equal to 2x plus 1 or something like that, while here in this case the y could be 2x minus 2 or something like that. Equation will come, because as x increases, the y actually decreases, or you can say 1 by x or 5 by x, something like that. As the y increases, x decreases. Right? So scatter diagram is used for regression analysis. It's used to establish relationship between two variables, or to check how increase or decrease in one variable impact the outcome. That is scatter diagram. So, and the last one is the run chart. Run chart is normally very simple. You might have seen it. It is used for trend analysis. That how we are performing over a period of time. My process is under control, out of control, any particular thing is going up or down, your quality over a period of time has gone up or gone down, or coming up, down, something like that. Basically doing the trend analysis. During the project, you can say how your risk profile is working. So initially risk profile is high, then it should low, then it again increase sometime, something like that. Basically used for trend analysis. These are the 7 quality tools which are normally used for planning, assurance and quality control. This is basically statistics method. So statistic method means to check that if the process is under control or not. Basically used for control chart. This normally doesn't come as such. This all calculation doesn't come in the exam and probably not use unless you implement some such type of things like Six Sigma or something. But what you should remember is that what is when we say 1 sigma, 2 sigma, 3 sigma, what kind of quality level we are talking about. So 1 sigma means 68.26% result should be good. 2 sigma means 95.5% result should be good. 3 sigma means 99.73% sample should be good. And 6 sigma means 99.99% result should be good. Once in a million chance that it may go wrong. This is 6 sigma. It is basically used for capability of this, that upper tolerance limit and lower tolerance limit divided by 6 sigma. 6 sigma means plus minus 3 sigma, make it 6 sigma here. So if this value comes to be 1, then it is process is capable. Greater than 1 means still the process is capable. Less than 1 means the process may not give you results of 3 sigma quality. That means the error will be more than expected. Means that good samples will be less than 99.73%. This is just one example which is given here with this. So here the value of the CP is coming 1. It means whatever the machine which is producing this has produced this data is actually capable of delivering 3 sigma results. Now there are 3 things in this: plan quality, assure quality and the control quality. So plan quality is basically talking about that considering all that cost which is coming in the quality. So one is cost benefit analysis. Why cost benefit analysis in quality? Because every quality management thing required an investment. Managing the quality required investment, and therefore we should check if this investment is giving intended outcome or not, or whatever the outcome is giving particular action, what the outcome is giving, is that okay? If the cost benefit analysis is fine, or the benefits we are getting by investing into a particular quality is okay or not. So therefore we do cost benefit. Cost of quality we just understand. We use 7 basic quality tools we just discussed about. A benchmarking means we have industry data, we have company data, or we have a countrywide data kind of things, and we benchmark, we compare against a particular standard where we stand. We are better than industry standard, we are less than industry standard, we are at par with the industry standard. So benchmark is some kind of a standard in front of us, and we compare our project results against that benchmark. Right? Design of experiment, statistical samples. There are few of the tools and techniques which are normally used in various tools. There are a lot of tools actually, not only these. But what is important here that we should take care of this cost of quality, 7 basic quality tools. Sometimes benchmarking. Some additional quality planning tools can also be used there, because there a lot of research has happened in quality So therefore, there are many tools available in this. What is our aim for the quality management is to prepare a quality management plan and process improvement plan. To prepare a quality management plan, that how we are going to manage the quality on this project, what is our quality matrix, what all parameters we will measure on this project to manage the quality, and any other checklist, etc., which we need to produce to ensure the quality of the product. So cost of quality we have discussed, cost benefit analysis we have discussed, 7 basic quality tools we have discussed. Design of experiment is also to identify which factor actually influencing the outcome most and then attacking that particular factor. Statisticals is very much used in, especially in Six Sigma kind of stuff. Additional planning tools may be something like field force analysis. Many tools are there. Any tools you can use. Yes.
What is design of experiment? How it works?
Design of experiment is basically, as I said in the regression analysis or scatter diagram, that we find relationship between X and Y. The design of experiment is normally used to take one factor, increase and decrease, and see that how the outcome is getting impacted. Then take another factor, increase and decrease, and see how much the outcome is getting impacted, and identifying which factors are actually influencing most the defect or the problem, and then seeing that where to correct it.
So do we need to simulate simulation of data? We use that?
Say it again.
Simulation of data?
I didn't get again.
No, put the data in Excel sheet. Put
Yeah. Most of them can be done through Excel sheet as such. It is something like you have an outcome, right? You have a parameter X. First you see X increases or decreases and how this outcome impacted. So you are where the point is coming. Then you take Y. You say, okay, what is the impact of Y? When you increase and decrease, how it makes impact on the defect. So which actually the parameter influencing the defect most, or the issue most, or the matter whatever we are measuring the most, that we need to find out. And that is the reason for, that is the main purpose of the design of experiments.
So once we find what is impacting that, so we have to work on that?
Yeah, of course, that is the reason. If you identify but don't work on it, then the purpose will not be solved. It's like you identified that you have fever but don't take any medicine. Okay, so as an output, you get a quality management plan. What is the quality policy? Frame the quality policy of the project. If it is exactly as per the organization policy, or it has some differentiation, or it has some gap which you fill. Process improvement plan, how the process will continuously improvised. The matrix which you're going to measure during this project. Checklist to see that the process, normally checklists are ensure that the completeness of the process. So for to check every process, you normally prepare a checklist, and when you audit the process, you normally tick the checklist so that you are sure that you have checked everything whatever supposed to be checked. That is the main purpose of checklist. So you produce all those things to go into execution. During execution, you do quality assurance activities. Quality assurance activities are mainly quality audits walkthrough, or you can use some quality management tools or process analysis. The process analysis is one of the tool in the quality assurance. So quality assurance is basically a proactive approach. It is done during project execution. And if you identify some kind of issues, you create a change request. Because these assurance activities, this quality matrix could play in plan, process improvement plan can play role, and quality management plan can play role. There are many things which are normally used for various other purposes as well as the quality assurance, but the main thing which uses is a quality audits. So audit means you can do a review, you can do some kind of walkthrough, you can check the process and identify if there is any gaps or shortcomings. And then you can also propose the corrective measures. Ultimate aim is the cost of quality should be reduced. So more you spend in the planning and assurance, less you need to spend in control, and therefore result into reduced COQ, that is cost of quality, and increase the customer satisfaction. The process analysis is also one of the tool which is normally used. The idea is to improve the process. So whatever the issues come up, whatever the problems come up, we normally analyze them, try to identify their root cause, and develop some corrective and preventive actions, take preventive action so that in future such things do not come again. That is the process analysis. In the change request, you can raise a change request in making the changes in quality documents, that is quality policy, procedures, process, checklist, project plan, or the quality management plan, assurance plan, any of those things. In all these process, seven basic quality tools are used. The last one is quality control. The idea is get the quality management plan, quality matrix, checklist, and the work performance data which is normally collected during execution. Approve change request to check that change request is also implemented perfectly. So quality control measurements, that is plan versus actual. Then you see the verified deliverable. You know, see, I said quality control, verified deliverable. This verified deliverable is an input in validated scope. Sorry. Verified deliverables. Verified deliverables is the input to the validated scope. Verified changes are basically, they are also part of deliverables. So changes are also part of deliverables. But verified deliverables means that the approved change requests which were executed now checked and found verified. Work performance information, that is plan versus actual, and the change request. If any deviation you found from the quality policy or procedures. This is not plan versus actual, but actual data. When we say data, it is this plan versus actual is not compared. That is the outcome actually. So this is not right actually. Basically only data which is collected during project execution, that is what goes as an input. Use 7 basic quality control tool to check that the quality of the project, do some statistical sampling, do inspection, walk through the audit, reviews, etc. during the project execution, so that whatever the end result which is coming, it should be of quality. and the outcome is quality control measurement. You know, we say matrix and measure. So matrix we already defined in planning, and now we are talking about measuring those matrices. So what is the value of those matrices? You get validated changes and verified deliverables. Work performance information, that is plan versus actual, and then the change request if there is a deviation. This is about quality management. Any question? Okay, so let's get started. What about question number 1? A. Comparing actual or planned project practices to other comparable projects within the organization or outside to identify best practices, generate ideas for improvement, and provide basis for measuring performance is called. See, when we do quality audit, now we don't compare actually. The comparison is normally happen in benchmarking, isn't it? Benchmarking is when our project's outcomes are compared with the others ones. Then it is called benchmarking. So in quality audit, we just go and see that the things are right or wrong, or not proper, or they are following best practice or they are not following best practice. But we don't compare the two projects or multiple projects as such. Make sense?
Okay. So what should the answer?
Answer is C.
Okay.
Question number 2.
D.
Okay, so B, D, T, B. Who should write project quality policy? See, quality assurance group can write quality policies for organization or for group or for a unit for a organization, but project quality policy should be written by the project team. And when we say project manager is responsible, but project manager doesn't do anything alone. It does it do with the help of the team. So C is more appropriate than D. The quality assurance group can write policies for organization group which are in general actually, not specific to a project. For a specific project, only the project people should do it. We are talking about the project quality policy. Right? What about 3?
So is it C is responsible?
Yes, it is C. Project team. This is simple, right? Question number 4. Well, Rajesh, your chat is coming, right? Good. Good, good. All C. What about question number 5? Question number 5. D, 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 all D. Okay. Question number 6.
Question is not visible. Can you please?
It's visible now, right? 6A, right? All A?
No, isn't it when we discuss that we say quality is meeting the customer expectations and or basically based on the requirements, correct?
Actually, that's what I'm saying.
Meeting expectation.
Basic, okay, I tell you, the thing is that I said two things: meeting our commitment, delivering what we said, actually. So meeting the customer expectations or exceeding the customer expectation may not be right in this term, because quality is more defined as the degree to which the project meet requirements. So requirements are given by the customer. We said, yes, we are going to deliver this or not. You said you write a quality requirement document. Requirements are given by the customer, but we write a requirement document and get it signed off by the customer. If the customer expectations are there, then customer expectations should be set by us. Actually, quality is defined in multiple ways. So one is degree to which the project meet the requirement. Second is it should fit for the purpose, fit for the use. It should solve the purpose. But normally, if somebody asks you a question that what is quality, it is A, which is more appropriate. You might have confused because I said that it should meet the expectation. So my purpose was to meet the expectation is actually telling that deliver what you said. That is what my purpose was. Okay. What about question number 7? E, right? Question number 8.
Yes, it's not visible actually.
It's not visible.
Yeah.
Question number 8.
If you can go up, it's not in the options are not visible clearly. If you can.
Okay.
Yeah, it's not okay.
Scroll down.
Question number 8. B, right? What about 9th?
Again, question is not visible.
Yeah.
You
It's
can.
taking little time to refresh. I think it is available now, right?
Yes, now it is available.
A little lag which I am seeing here. But Amitabh, you will be having a handout, right? What about 10th? It's all going well. All C. Very good. What about 11? All B. Very good. What about 12?
For the 11, I think even A looks similar, no?
Project quality assurance
Yeah.
includes measuring conformance of the project team to specifications and provide the project team with a standard to measure the project performance. No, sorry. I think I'm.
No.
We have to. Okay. You are the project
11.
manager of highly visible project. The project is running bit late and team is under pressure to complete the project as soon as possible. A quality auditor from quality group approaches you and he has to do an audit of the project. Your team raised an objection on the audit at this point of time. What do you explain to your team? Regular audit is an organization mandate and team has to comply. The audit is for identifying inefficient process and policies. This will help team to more productivity. See, which is a better explanation. Actually, we have to see this. Now, A looks like in Hindi, if I say boja, a bureaucratic thing.
Yeah.
This is an explanation which make the process audit a bureaucratic thing because there is no rational. It's like it is a thing, we have to do it. It looks like a bureaucratic because it's not giving any benefit. While B talks about if we do it, there is a benefit to us, not to management, which is true actually.
No, it looks more appropriate, but it's still one will also looks correct because the only thing is autocratic.
A is autocratic and normally used by the managers who themselves do not think that why audit is happening. So how they explain to their team? They don't explain actually. They say, oh, it is coming from the top. You have to do it. That's not an explanation actually. There is a purpose for doing it.
Yeah, it's good.
Okay. What about 12th? All D. What about 13? What about 14? Looks like a quality management is a simple chapter, right? I think most of them have gone right.
Or maybe questions are maybe simple.
Or maybe the questions are simpler. Comparing to the project or to the scope. Okay, what about question number 15? Or the people are getting grasp of the things. So I said one thing, 4 things are already understood. Now the whole context is clear, right?
No, that's true. But very good thing I realized, Vivek, and that is teaching approach. It's not only just that you're following the sequence, rather you go the major part, important part first, and then you can you go the way. So it doesn't matter what sequence you're following, but you're covering everything.
Thanks. It is all B. Great, yeah. I think it is all 90 or 100% accurate. Eh? I think some people are 100%.
Yeah, looks.
Yes, so quality is good. Eh? That's great. Good. So it is 11 o'clock in my watch, and this is the time to close for today. Thank you very much for being here, and we will meet tomorrow at 7 o'clock India time. Same. We will start with human resource management.
And Vivek, tomorrow I would like to have a break around 10:30. So when we do the break, if it is 10:30, that will be much better, because in my place deployment is going on.
Okay.
And 10:30 to 11 I have a status call. So that will be great.
Okay, so we can do that way if all agrees that instead of taking a break, we will don't take the break and finish the training at 10:30. Because taking a break at 10, it is your 10:30 or my 10:30?
No, my 10:30 means your 9 o'clock.
9 o'clock. So take a break at 9 o'clock instead of 8:30. That is fine.
Correct.
Anyway today we took at 8:55 almost. So we'll take a break at 9
Most of the time we do almost I think in India time 8:45 to 9 o'clock only. But if it is 9, that's better.
Okay, we will take a break at 9 o'clock. Not a problem.
Yeah. Okay. Thanks.
Yeah. Thank you. See you tomorrow.
Thank you.